From the earliest conception of strategic bombing, there has existed a requirement never previously fulfilled for fighter protection of bombers when over the target area. Now it appears bombers may tow two jet fighters to the target and back virtually without reducing their radius of action. This recent development of the Air Materiel Command paves the way for fighter escort protection and the solution to this heretofore unsolved problem. Calculations and tests made by the Air Materiel Command, private industry, and the National Advisory Committee for Aeronautics indicated that by coupling two fighters to a bomber by means of wingtip mechanisms, fighters could be towed by the bomber almost free of charge. To prove the scheme workable, the Republic Aviation Corporation at Farmingdale, New York was awarded a contract to carry this project through to a successful conclusion. Here, the coupling mechanisms were installed using one B-29 and two F-84 fighters for the initial tests. Lances, one mounted on the right wingtip of the F-84 and one on the left wingtip of another, were designed to fit into retractable sockets mounted on each wingtip of a B-29 bomber. The lance enters the socket on the wingtip of the B-29 and automatically locks in place. The socket is then retracted hydraulically, thus drawing the F-84 wingtip flush against the wingtip of the B-29. While it increases the weight of the F-84 aircraft about 120 pounds, the mounting of the lance requires no additional strengthening of the wing. A switch located inboard of the lance actuates a piston which rotates the lance tip 90 degrees. A roller mounted at the rear spar of the fighter wing seats in a V-fork on the B-29 wing to provide for centering the fighter correctly in pitch. When the roller seats in the fork, it actuates the rear latch within the bomber wing. This locks the fighter to the bomber in pitch and yaw. While the lance head is locked relative to the B-29 socket, the F-84 can roll about the lance shaft. A mechanical connection between the lance shaft and the F-84 ailerons functions automatically to restore the fighter to normal flight position if any displacement in roll occurs. This feature provides hands-off flight for the fighter pilot. A snubbing cylinder to take the impact of the fighter aircraft was also provided. A sponge rubber bumper was provided to make a tight seal between the wing tips of the two airplanes. The normal position for engagement is with the socket extended 19 inches. Thus projected out of the major portion of the B-29's wingtip vortex, it enables the fighter pilot to effect a coupling more easily. These modifications increased the gross weight of the B-29 by 700 pounds. However, only local reinforcement of the wings was determined necessary. The accompanying animated diagrams illustrate the principle of the floating wingtip mechanism and how it operates in flight. After the bomber has extended its socket, the fighter approaches the bomber and inserts its lance into the socket. The socket depresses a small button on the leading edge of the fighter wing. The button actuates a switch which causes the tip of the lance to rotate 90 degrees inside the socket. This locks the fighter to the bomber in tow. Since the lance is oval in cross-section, it cannot rotate within the socket. The socket is then retracted, drawing the fighter wing tightly against the bomber wing. The rubber bumper along the bomber wingtip seals the air gap between the two wings. While the fighter is being drawn toward the bomber, a roller mounted on the rear spar of the fighter wing is guided into a forked fitting on the bomber wing, thus fixing the pitch of the fighter relative to the bomber. As the roller seats in the fork, it depresses the button which actuates a switch, causing the rear latch to emerge from a recess in the bomber wing to slip over the end of the roller shaft. This locks the fighter to the bomber in yaw. The fighter is now locked to the bomber in tow, pitch, and yaw. It is free to roll about a shaft buried in the fighter wing which connects the fighter lance to a gearbox which is in turn connected to the aileron control of the fighter. Now, if the bomber banks into a turn, the shaft is rotated. This displaces the ailerons on the fighter so that the fighter aligns itself automatically with the bomber. This automatic control was provided to prevent fatigue of the fighter pilot and to guard against and take immediate corrective action when an unexpected gust is encountered. A cam mechanism is built into the shaft, which allows the fighter pilot to override the automatic aileron control at any time. Emergency disconnect switches are provided for both the bomber and the fighter pilots so that each can separate instantly from the other at will. On July 21, 1950, the first B-29 bomber to be equipped with the new floating wingtip mechanisms took off the runway for a coupling test with an F-84 fighter. On this date, Major C.E. Anderson of Air Materiel Command's Flight Test Division made the first successful coupling to the wingtip of the B-29. 4 successful couplings were made this day. The average time to couple varied from 2 to 10 minutes, and the total couple time was 30 minutes. On July 30th, 1950, Captain J.M. Davis, also of the Flight Test Division, successfully coupled to the left wing of the B-29. During this flight, Captain Davis experienced a partial loss of aileron boost, but still was able to effect 2 couplings with some difficulty. Several more couplings were successfully accomplished by both the left and right fighters individually in order to gain more pilot experience. On August 22, 1950, both fighters were simultaneously coupled to the B-29 for the first time. Up to the present, the 3 coupled airplanes have been flown at altitudes from 10,000 feet to 20,000 feet and at indicated airspeeds ranging from 180 miles per hour to 230 miles per hour. Shallow turns have been successfully accomplished as well as climbs and letdowns and hands-off flight. Drag and stress were recorded under all of the test conditions. The engines of both fighters have been completely shut down for several minutes at a time, and successful air starts have been made while coupled at all altitudes. Normally, the engines are left idling at approximately 18% power in order to provide enough thrust to overcome the windmill drag of the F-84 engines while recording the total drag of the coupled airplanes. 15 flight tests have been completed, during which over 90 couplings were accomplished. 1 night flight has been made, during which 4 couplings were completed on each side. Data from these tests indicate that 2 F-84 aircraft could be towed by a B-29 carrying 10,000 pounds bomb load with a reduction in range of only 2.9%. Several changes are now being made which will result in an operational combination. The original installation was designed to obtain data over relatively short flights. Therefore, no provisions were made to change the relative angle of pitch between the 3 airplanes. It was discovered during the flight test program that the mechanical system of controlling the position of the fighters in roll is marginal. It is believed that a new control system, to be hydraulically operated, and using only the outboard ailerons of the fighters for control of roll disturbances after coupling has been effected, will provide necessary stability. F-84 engine shutoff doors will be installed in the air ducts in order that the fighter engine can be completely shut down without adding windmill drag to the combination. These changes will necessitate installation of various controls and equipment to provide services during towed flight that are normally provided by the main power plant. A refueling connection will be provided to enable the fighter to fly more than one mission, and pilot comfort and extra oxygen will be supplied. In operational use, it is anticipated that the bomber and fighters will take off independently and rendezvous in flight en route to the target. The fighters will then couple to the bomber, shut down their engines, and be towed to the vicinity of the target area by the bomber. Here they will uncouple from the bomber. They will be free to escort the bomber into the target area and out again. They may do individual reconnaissance missions. Once out of the target area, they will recouple to the bomber for the tow home. It should be borne in mind that this installation was designed for test purposes to provide engineering data and not considered at this time to be a prototype installation.